heavily conceptual problems. And I'm just gonna walk through like the mental process that I do as I think about these, okay? Because they're not necessarily all that mathy. They're just conceptual. So if you can understand what you're doing, then the math is okay. But if you can't understand what you're doing, you basically can't do them. All right? So Court, we got to get the headphones out, please. Thank you. All right. So it says, what is the remainder when you have f of x divided by x minus 3? So we have f of x is divided by x minus 3. And so since you're taking f of x and dividing by x minus 3, if you were to do synthetic division, what is the number that would go in the little box? 3. 3 is the number that would go in the little box, x equals 3. And the remainder is the answer that we are trying to get, right? The remainder is the answer we are trying to get. So if I were to do synthetic division, I would put the 3 in the little box. I would have blah, 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 all my coefficients right there. And my little remainder would go here, right? Is that true? Okay. Now, the remainder theorem tells us that if we do f of 3, we get the remainder as the answer. That's one of the things we learned from the remainder theorem, is that there's a connection between doing synthetic division or long division and getting the remainder, but then also evaluating a function, that there's an interesting connection here. Okay? Now, I don't have an equation to plug 3 into, but I do have a graph where I can look at an x-coordinate of 3 and I can see what the y-coordinate is that corresponds to that. So if you look at the graph, when you look at the x-coordinate of 3, what is the y-coordinate that corresponds? 6. So x-coordinate of 3, y-coordinate of 6. There's the point right there. We have 3, 6. So that means that f of 3 is 6, which means that your remainder was 6. Okay. Are there any questions, anything that came up from that that I could clarify? Okay, the next one is a two-part question, okay? So we're going to focus on the first part, which ends at the first sentence, okay? It says if you take f of x, which is x to the third minus 2x squared plus 13x plus k, and you divide it by x plus 1, the remainder that you get is negative 8, okay? But depending on how you like to do these, there are two ways to do this problem. And when I was helping people around the class, I saw both ways represented depending on how people thought about the problem, okay? So if you look at this, we would set this up with synthetic division, right? And we have the actual function. So if we do synthetic division, what number would go in the box? Negative 1. We'd say x equals negative 1, okay? So negative 1 would go in the box. All right, and then what are all the coefficients if we write them down? Okay. And then when we get done, what's our remainder going to be? Negative 8. Court, you with us? All right. So you can do actual synthetic division with this if you want to, okay? The other option is to use the idea that we learned from the remainder theorem, which is if you take the function and you plug in negative 1, you're going to get negative 8 as an answer. So some people chose to do the synthetic division way. Some people chose to plug in negative 1 knowing that it would equal negative 8. I think the two ways are equal as far as difficulty goes. I think they're about the same, okay? So as far as what I show the class right now, which way would you guys rather do it? Synthetic division or plugging it in? Plugging it in? Okay, so let's do this. So we would take the function itself and plug in -1. -1 to the third minus 2 times -1 squared plus 13 times -1 plus k equals -8, right? So that's one of the things we learned from the remainder theorem, was that if you plug in -1, you get the remainder as an answer. So I'll go ahead and just check and see what this equals. So -1 to the third minus 2 times -1 squared plus 13 times -1, that's -16. So I have -16 plus k equals -8. So how can I finish solving for k? Now I could just add the 16 over. So k equals +8. Okay? So I have finished the first part of the problem. I had one unknown value. The unknown value was within the function itself. It was that there was a k that I didn't know. So k equals 8. So now I can go back to the problem and I can say, okay, this value right here is actually 8. Now I can look at the second part of the problem. The second part of the problem says, what is the remainder if you take this and divide it by x minus 2? Okay, so now I'm going to take x to the third minus 2x squared plus 13x plus 8 and divide it by x minus 2. So same thing, we're going to set up that synthetic division problem. What number goes in the box? X equals 2, right? So we have 2 in the box. And then this time when we set up our synthetic division, we don't have a k on the end because we actually know what k equals. We've done the first problem. So we can say 1, -2, 13, and 8. And the answer that they want us to get this time is they want to know what that remainder is. So again, we have two options. We can do the synthetic division problem as synthetic division and get the remainder and say that's our answer because they said, hey, what's the remainder? Or if you guys want to do f of 2 equals r and just plug 2 into the function and get an answer, we can do it that way. It doesn't matter which way you do it because both ways are going to give you the remaining value, which is what they want. Remaining value. So which way do you guys want to do it? Do you want to do synthetic division or do you just want to plug in 2? Just plug in 2? So I'm just going to go up here, change all these to 2's. 2. 2. 2. And then I'm going to make sure that I put plus 8 on the end. That's the plus k value. So I get my remainder is 34. So f of 2 equals 34, which means that if I had done it with synthetic division, I would have gotten 34 over here. So the remainder is 34. Are there any questions on that problem? I knew that the problem had two parts because the first part had an unknown, it had a k. And the second part had an unknown, it said, what's the remainder? So there were two unknowns, which means there were two things that I had to solve. That's how I knew. Okay. It says, so number 9 says, given the function that has these two factors, find the third factor. So when they phrase it like that, they're saying what they mean is that g of x can be written as one factor times another factor times another factor, and they want you to find the three factors that it can be written as. So when I did this problem, I took the problem and I divided it by one factor, and then I divided it by another factor, and that found me the third factor. I noticed this group over here. Can you guys tell me what you guys did? Because I thought you guys did it a really interesting way. Yeah, so they took these two factors and they multiplied them together first. And then instead of dividing twice, which is what I did, I divided by one factor, then divided by another factor. So instead of doing that, they just multiplied these together, and then they took this and did long division and divided it by both at the same time. So they only had to do one division problem. So it kind of comes down to what type of division you're most comfortable with. The method that I did had me doing synthetic division twice. The method that they used had them doing polynomial long division once. Okay, so both methods work. It's just a difference of how you think of the problem, but they both work. Okay, so what I did is I said, let's go ahead and take this problem, 2x to the third minus 11x squared plus 2x plus 15. And it doesn't matter which one you divide by first, you just pick one to divide by. So which one should we use first, the x minus 5 or the x plus 1? X minus 5. Okay, so when we do that for synthetic division, that means the one that we're putting inside is 5. So I put 5 in the box, and then that gave me a 2, a negative 11, a 2, and a 15. And with this, we actually have to do the synthetic division. We can't use the remainder theorem here because we need to know what the answer is. Now, since these are factors, what's the remainder going to be? 0. And that's going to help us make sure that as we do this synthetic division that we're doing the problem correctly. So I drop down the 2. 2 times 5 is 10. Add those together, get negative 1. Negative 1 times 5 is negative 5. Add those together, get negative 3. Multiply those, get negative 15. And those add to 0. So that means that I am on the right track. Okay? So what I have now is I have 2x squared minus x minus 3. So I'm going to take this result. When I took this and I divided it by x minus 5, I got this as an answer, and I'm going to continue to divide, and I'm going to take this and I'm going to divide by x plus 1. And when I divide by x plus 1, it's going to help me further break it down to find that last factor. So I know my first factor is x minus 5. My second factor is x plus 1. So I'm going to do the process again. I'm going to divide by negative 1. I've got 2, negative 1, and 3. This is a factor, so my remainder is going to be 0. Drop down the 2. 2 times negative 1 is negative 2. Negative 1 and negative 2 gives me negative 3. Since that had an exponent of 2, that means this is just going to be an x. So this is 2x minus 3, which is the remaining factor. 2x minus 3. So this is what g of x is if you write it down as 3 factors. So 2 different ways of doing the problem. It just kind of depends what your comfort zone is. So if you are comfortable with the polynomial long division where you're dividing by a quadratic, then you could have taken this. If you multiply these together, you get x squared minus 4x minus 5. You could have taken that and you could have done a long division problem where you have 2x to the third minus 11x squared plus 2x plus 15. And you divide it by x squared minus 4x minus 5. And if you do that long division problem, you get the same answer. 2 different ways of doing it. Say it again. I foiled this in my head. X squared plus 1x minus 5 makes negative 4. Joseph, would you mind shutting the door for me? They're studying Helen Keller. All right, any questions on number 9? So whichever way you choose to do a problem like that is totally fine by me. Okay, number 10 says that you have an X-intercept. So they gave you the 0.30, which really means that you had f of 3 equals 0. You plugged in 3, you got 0 as a result. So if we were to set up synthetic division, what goes in the box? 3. 3 would have gone in the box. And what would the remainder have been? 0. All right, so they said that you had one X-intercept, and we know that X-intercepts actually are always factors of the problem. So this means if you have an X-intercept, it means that this is divisible by x minus 3. That's what that means. It's divisible by x minus 3. That's what having a factor means. So when they're telling you to find the other intercepts, they're telling you to find the other factors. So it's the same as problem 9. It's just phrased a little bit differently. And they gave you less information. So we're going to take this problem. We're going to put the 1, 2, -9, -18. I'm lining up the -18 over my remainder. And I've got 1 times 3 is 3. That's 5. 5 times 3 is 15. That's 6. 6 times 3 is 18. And since that was x to the third, this drops by 1. So we have x squared plus 5x plus 6. This is going to equal 0, because if they are x-intercepts, then the output is going to be 0. Whatever you plug in, the output is going to be 0 for x-intercepts. So this fits what we're expecting, 2 x-intercepts. This is going to give us 2 answers. And when we have 2 answers from something like this, how do we solve it? Factor. So we're looking for 2 numbers that multiply to 6 but add to 5. 2 and 3. X plus 2, x plus 3. And so what are the 2 solutions? -2, -3. So the 3 intercepts for that problem would be +3, -2, -3, which you can see if you graph it. Okay. So I think all of these problems were difficult and none of them were the same. They were all different approaches. Okay, but all of them I did take from like EOC practice problems, and so I didn't want to give you guys a worksheet where I had 5 of each one because I thought that would be very long. But I wanted you guys to see each type. So if we were to continue practicing these to get you more comfortable with them, how would you guys like me to help you guys practice these without you guys wanting to like gouge your eyeballs out? Say it again? Yes. Ten was okay? You guys don't like number 7? I thought number 7 was kind of like, oh yeah. Yeah, number 7 is like, give me more of those. Number 7, if you understand it, number 7 you can do in a pinch. But if you don't understand it, no thank you. But if you understand it, you can get to it real quick. I'm thinking maybe if we just do like, if I just like throw one on a worksheet every day. Just like a warm-up question. I gotta like desensitize you. I gotta get you to the point where you're like, yep, we got them. Let's move on. We get it. We get it. We get it, Ms. Rice. Okay. Let's finish the notes. So tell me, what did I not get to? Oh, I did all the front side? Yes. Okay, I just didn't do 4, 3, 4, 5, 6, 7. What did I not do on the back?
3, 4, 5.
Marvelous. Okay. Yes.
I left my notes at home, but I got a new piece and I copied them all down today. So I'm just gonna.
Okay. You could. There's extra copies over there.
Well, I know news were a little bit.
Okay, but I'm saying you could grab it now if you just want it to look like this. I have like a cat hair in my eye or something. So if you see me rubbing my eye incessantly, it's because I'm just rubbing that cat hair further in my eye, in case you were wondering. Okay, just so we're on the same page. Okay. All right, number 3. What are the x-intercepts that we can see for number 3? -3 and 4, okay. X equals -3, x equals 4. Ooh, we gotta do, can we tell what the degree is? Degree is 4, so 2 plus 2 gives us 4, okay. Now, when we look at this degree of 4, that's an even number. Is this a positive coefficient or a negative coefficient? Positive, so what does that tell us about our arrows? They go up, up, up. Now look in the back, there's a poster for this. So it says, it's on the right side, at the top it says end behavior. Even degrees at the top. So this is kind of like a little like cheat sheet on the back wall for you guys, where I'm telling you even degree versus odd degree, positive coefficient versus negative, so that if you have a brain fart and your notes are not handy, then you have some stuff to fall back on. I also have long division, remainder theorem, and stuff like that I can like walk over to the wall with you and we can point to stuff. All right. The other thing is I'm pretty sure I'm going to have you guys use a cheat sheet on this unit for the quiz and the test. Like a sheet of notes on the quiz and the test. Like, yeah, I'm not going to tell, well, I'll probably give you a list of things you should write on it, but I'm not going to write it for you. I'm going to make you write it, and then if you choose not to write it, that's your own fault. 8.5 by 11, sheet of paper front and back. No, you cannot split the paper down the middle. You cannot peel it apart to maximize your space by writing on the inside of the paper. Yes. You can printer paper is the most you can maximize size. So if you want to you're like, I want to use a bigger sheet of paper, use printer paper, not notebook paper, because notebook paper is slightly smaller than 8.5 by 11. 8.5 by 11 is printer paper. You can type it, but typing math is very difficult. You can do front and back. You can bring a magnifying glass. You cannot photocopy someone else's cheat sheet. Miss Rice, why can't I? Because the cheat sheet is it's a two thing. It's double purpose. So you study as you make it, and then it benefits you while you use it during the assessment. So I want you to study while you make your own. I don't want you to try to use someone else's and not the benefit of it. Now, if you're going to try to sneak and photocopy someone else's behind my back, then whoever you let photocopy your own, you should charge them. I'm just saying. Make money off of it if you choose to do it. I am not grading them. Yes. I will not see them. Yes, front and back. Any other questions? You can put formulas, you can put example problems. No. If you want a graph on it though, you can like print a graph so that so you don't have to like draw graph paper. You could, if you want like a picture of something drawn well that you cannot draw well, you want like a graph that looks nice, you can print that. Yes. No. Good question though. I promise you guys, the act of sitting down and doing the tedious work of looking through your notes and picking examples, that work is actually a good method of studying for a math test. That is how you study for a math test, is copying examples down. So the act of you making the cheat sheet is actually very effective for studying. And if you do it a lazy way by like photocopying something and shrinking it down and do it in 5 minutes without looking at it, number one, you're not going to be familiar with your cheat sheet. But number two, it's not effective studying. Does that make sense? So you taking, like my calculus students, when they do their cheat sheets that I grade for credit, they spend 3-4 hours making their cheat sheets, and it's probably the most effective studying they do for their tests. It is super tedious, but it is very effective as far as studying goes. So, any other questions about cheat sheet? No. All right. Okay, so we have the end behavior. We got our left arrow going up, our right arrow going up. We have our x-intercept at -3 and at +4. What is the multiplicity for each x-intercept? 2. So that means that each of these is going to bounce off the x-axis. They're going to look like mini little parabolas sitting on the x-axis. So we got 1, 2, 3, 4. 1, 2, 3, 4. Arrow going up, arrow going up. Okay. So, if I need to connect to my up arrow, should my mini parabola be above the line or below the line? It should be above. It's the only thing that makes sense. Okay? You didn't do the little what? The J?
Yes, you see how it makes a little J?
Backwards J?
Yeah.
Did you do a little parabola? Did you do a little parabola? Did you make a little bouncy? Are we both speaking English right now? Okay. The next one. At 4, we've got another little parabola, and we have to connect to the first parabola, and we have to connect to the arrow. Should the parabola be above or below? Should be above. Okay. And then, do I connect the two lines just by going like this? No. Why can I not just connect them like this? Why can't I just connect them with a straight line like this? You just can't. It's not what polynomials look like. They have smooth curves. They just are curved lines. So you can't have any sharp corners. It has to be a smooth curve, okay? Now, you can be creative with this because if you notice, we did not label the y-axis with any numbers. So if you want it to be kind of like a shallow thing like this and you want it to just look like that, that's fine. If you want to get like real funky with it and you want to be like, Ms. Rice, I feel like it goes up like this, by all means, go for it. I don't care. Sure. You don't do extra curves because that would be something. But you can make it kind of tall if you want. All right. Next one. What are our x-intercepts? Or actually before this, sorry, degree. The degree is what? 5. 3 plus 2 is 5. Now we're going to use the negative. The negative is the coefficient. So if the coefficient is negative, what does that tell us about our arrows? Yeah, so overall we're going to we have an odd, so that means the arrows go opposite directions, and they have to have a negative slant, so they go up first, and then down. So odd, think of parabola, the arrows agree with each other, either both up or both down. Positive is up, negative is down. An odd graph is easier, I think, because it's either a positive slant, so it goes down up, or it's a negative slant, it goes up down. You just have to like back away from it. Don't be too close. You have to back away from it so you can see what's happening overall. Is it overall a downward slope that goes up, down? Or is it overall a positive slope that goes down, up? But if you're looking at it too closely, you get distracted by the squiggles. You have to back away so you can see like what the overall slant is. And then you can kind of tell what it's doing. Yes? Where did I get the what? The 5 is 3 plus 2. The exponents. 3 plus 2 is 5. Yep. All right. The x-intercepts are what? Okay. The multiplicity for 7 is 2. Multiplicity is how many times that answer happens. So this means x equals 0, x equals 0, x equals 0. This means x equals 7, x equals 7. So multiplicity just tells you how many times that answer happened. Multiple times. All right, so, and then 0 has a multiplicity of 3. Okay, so we've got X-intercept is 0, and then 1, 2, 3, 4, 5, 6, 7, all the way over here. I got an up arrow and a down arrow. Right? Now, multiplicity of 3 is what students have the hardest time drawing. So, we have two options. We have go up, level off, go up. That's one option, okay? Or go down, level off, go down. Was it the first one or the second one? Second one. So we're going to start at the arrow and we're going to go down. We're going to level off as we go through the x-intercept. So go down, level off, and then go down. So it crosses through, but it kind of squiggles as it crosses through. It doesn't go straight through. Straight through is a multiplicity of 1. Yes. What? Yes. All right, and then multiplicity of 2 for the 7. What does that look like? Multiplicity of 2. Parabola. So we could have this one or this one. Second one. Wade already knew. He told me. He told me first. All right, so it looks like that. And then how do we connect them? Smooth curve. Whew. And then some Miss Rice hair. Yes. Because polynomials always have smooth curves. The only time you can get sharp corners and things is with a piecewise function or with an absolute value graph. And since we don't have either of those, we're going to have smooth transitions. Yeah, good question. All right. So with the next one, anytime I have something like this, I like to put my ones in before I find my degree. So what's the degree of this one? 6. Wait, 6 or 7? 6? Okay, 6. That's okay. And then so this is even. This is an even number. Which way do the arrows go? Both down? One up, one down? Both down. Okay, down, down. Okay. What are the x-intercepts? Okay. So we've got multiplicity of 1, multiplicity of 1, multiplicity of 3, multiplicity of 1. I need another marker. Purple. Okay. Now, it is required that you draw the little notches on here, because if you don't, I just have to guess what the numbers are, and I'm going to purposefully guess wrong every time because it's fun. Yes? Now, you have to draw the notches on here every time because I just said so. Okay, just so we're clear. That was a good question. But you have to draw the notches on there every time. I went to push up classes that I don't have. It was a sassy response. Is that a tear? It's good. I can go home and tell my cat that I made a student cry today, and that makes us both happy. All right. X equals -5, multiplicity of 1. Okay, this is very, very complicated. Are you guys ready? Okay. Our straight line can have a positive slope or a negative slope. Positive slope. You guys chose right. Very good. Shoop. All right. -1, multiplicity of 1. Are you ready for this? Ooh, those are very similar. I regret my choice. I'm gonna do it anyway. Okay, we can do a positive slope or a negative slope. We're gonna have to do that negative slope. All right, negative slope. And how should I connect those two lines? Should I pretend it was an absolute value function? Shoop, shoop. No? Oh, I just miss that unit so much. You don't miss it? Okay, curved lines. All right, then we have 2, which is a multiplicity of 3. Okay, those look different. That's good. Okay, so we have 2 options. We can go up, flatten out, go up. Okay, that's one option. Or we can go down, flatten out, go down. Okay, so we gotta go up, flatten out, go up. And then we gotta connect these together. Okay. And then last one, we got our multiplicity of 1 at the 5. And we can do positive slant, positive slope there, or negative slope. Which one makes more sense? Negative slope. Okay. I mean, I'm just making a point that that your lines they shouldn't be straight up and down, really. Some students will draw them straight up and down, and it's like, well, technically, they don't do that. Well, they're slanty in a way that makes sense, right? Because when I did this, the positive slant is the slant that made sense. The negative slant does not. Over here, the negative slant is the one that makes sense. The positive slant does not. So there is a slant that makes sense. Nope. It is based off what makes sense. Yep. So you'll notice when I draw the graph, I draw it from left to right based on what makes sense. I cannot draw each individual piece ahead of time, and I can't just draw it from the middle. Yeah. All right. Last one. What is my degree? 9. I have a negative coefficient. What does that mean? Negative coefficient for an odd number. Up arrow, then down arrow. Okay, what are my X-intercepts? -4, +2, and 0. And just for funsies, they're all multiplicity of 3 because I was like, I don't think I've had enough practice drawing it yet on these notes. Yeah. Because of the X in the very front. The coefficient is 1, but that doesn't tell you what because this, if you were to put it in parentheses, would be x plus 0 cubed, which is why they didn't have to put it in parentheses. And so the opposite of it would be, that idea. But yes, you're right, the coefficient is 1. So the coefficient only tells you that there's no stretch or compression. The coefficient doesn't give you the actual X-intercept. All right. So 1, 2, 3, 4. 1, 2, 3, 4, 2, 0. Up, down. Yes. Yes. What do you have to leave? What? What? Yes. The notes are over there, behind James, underneath the assignment for today. Go ahead and grab today's assignment and grab the notes. So the assignment says something about linear factorizations, and the assignment says something about complex roots. No, no, you're right. No, you're not right. Sorry, the edge of the table not close to the wall. Close to the wall is old stuff, and then the edge of the table not close to the wall is new stuff. Yes, complex root notes is the one for over the weekend. Okay. -4, multiplicity of 3. So are we going up, leveling out, going up? Or are we going down, leveling off, going down? Down, down. Okay. And then for 0, are we going up, leveling off, going up? Or are we going down, leveling off, going down? Up or down? Going down or going up? Going up. Okay. And then for 2, are we going up? Or are we going down? We're going down. Okay. And then we do a little whoop. Twins. No? Evil twin. Okay. All right. I need your help writing equations. Oh no! I need your help. Oh no! Oh no, I need your help. What if you don't want to help me? Why wouldn't you want to help me? You guys are so rude. You only want to help me if you get something out of it? That's so hurtful. Okay. Talk to me. What do you guys see? Okay, so this is a parabola. Okay, so that's a little bouncy bounce right there. Okay, so we have an x plus 2 squared. Wait, is that a bounce? That's a cube. Okay, so it's not a bounce because it goes through. It crosses through. So it has to be either a 1 or a 3, and it doesn't go straight through. It squiggles through, so it has to be a 3. Okay. What is this one doing? Is that a bounce or a cross through? That's a bounce. Okay, so that's an x minus 1 squared. And then what is this one? That's a straight through. Okay. Let me put a y equals in front. Okay, now should we have a positive coefficient or a negative coefficient? Up arrow, up arrow. Okay. We feel good about our answer? Oh, I don't care. That's fine. No, this is good. This is good. I like it. You guys, that's perfect. We're done with that one. Next one. I have approximately 36. Okay, let's go. No, this is not an activity. I'm just making sure you guys are comfortable. Okay. I was joking. I don't have 36. I have a few, though. I think this one is too easy. Let's do a different one. Let's do this little guy. Do you guys like my whiteout job? Did I do a good job? No, sit down. You were late to class. Sit down. Sit. Sit. All right. We have what? Okay, x plus 10 to the 1. Then x cubed. Yeah, that was the tricky part. Does everyone see the x cubed right there? I put a dot so you could really see it. You like my dot? Okay, so you can see that it goes through, it crosses through clearly, and it doesn't go straight through, it like squiggles through. Does everyone see that? The squiggle through? Okay. And then what else do we have? X minus 10. It is very tempting to see these and call them parabolas. Now, why don't we call that a parabola though? Yeah, it's not on the x-axis, so that's why we don't care. The polynomials are going to have lots of little loops everywhere. We only care if they have a little curve on the x-axis where an x-intercept is. Does that make sense? So we're truly, we're ignoring everything else. We were just looking right here. We're ignoring everything else. We were just looking right here. We're ignoring everything else. We're just looking right here. Which is why when I did the previous one, see how we had this big parabola sticking over here? And I completely covered it up with a sticky note because it did not matter. The only thing that matters is the x-intercepts. That's the only thing that matters. Yep, so you basically are looking at mini parabola at the intercept. I care about that. Squiggle at the intercept. Parabola at the intercept. Straight line at the intercept. The rest of it we don't care about. Because remember, when we were drawing these and I was using my marker, the in-between stuff is the pencil. I didn't care about the pencil. Remember, the pencil you could do whatever you wanted with. But the marker, that little part, is the part that I cared about. Does that make sense? Okay, yes?
How would you like us to recognize the correct things?
The swoopy things in between?
No, the marker. Would you like us to use the marker?
Oh, I don't care. You don't have to use a marker. Okay. Just as long as you're drawing a mini parabola or to the third and having the correct curvature, as long as I can tell the difference between a straight line, a mini parabola, and a mini cubic, that curve through, as long as I can tell a distinct difference between those three things, you're fine. No, because I like to play devil's advocate. I'm glad we're on the same page. Okay. All right, next one. Let's see. Let's make sure we're really good at this before I give you your assignment. Okay, how about this one? What do we see here? X plus 1. So it's a parabola because it bounces. So x plus 1 squared. Okay, what else? X minus 2. Is it to the 1 or is it to the third? It's to the third because it doesn't go straight through. It's kind of got a curve to it as it goes through. Do you guys see that? Okay. All right, I think you guys are ready for the assignment. So the assignment has 2 parts to it. I'm just going to show them to you. So the first part is like this, where you are recognizing the different parts of the curve and you're writing the equation yourself. Okay, so the first part is recognition. Everyone see that? So here you are writing the equations out. Then after that, you get to this and you start graphing your own. Sound good? Make sense? Okay, so approximately 5